Select the major product of the following reaction. So in looking at this reaction, to decide what sort of reaction it's going to be, we want to look at what we are reacting. So as a starting material, we see that we have an alkane. And we see that we are reacting this with molecular bromine, a halogen, and we're using light. And so light can be used to initiate a reaction. And in this case, the light is going to initiate a radical reaction because the bromine-bromine bond can be cleaved to form bromine radicals. So this is going to initiate the radical reaction. And so what we see is going to happen is we're going to have a radical halogenation of an alkane with these conditions. And this is really the only reaction of alkanes that we know. Alkanes are very unreactive because we don't have any leaving groups on there, we don't have any pi bonds, and it's a very nonpolar molecule, so really not very much that can occur. So in this reaction, what we're going to have take place, as we mentioned, the light is going to initiate a radical reaction. So if we have the bromine, and we have light, then this is going to allow the bromine-bromine bond to cleave to give us bromine radicals. And there will only be ever a small amount of this taking place at one time. You're not going to have a large concentration of bromine radical. So only a small amount of the bromine is actually going to be converted to the radical. And then this radical can react with the alkane. And so when it reacts with the alkane, what it's going to do is it's going to abstract a hydrogen to give us HBr, and then it's also going to form a new carbon radical. So we need to know where that new radical is going to form. And so the stability trends that we see for radicals are the same as what we see for carbocations. So if we're looking at this alkane, we see we have a lot of secondary carbon atoms in the ring and right here. We have a primary carbon atom and we have a tertiary carbon atom. So that tertiary radical will be the most stable. So that's where the bromine will react. So we will be forming HBr by taking one electron from the carbon-hydrogen bond and the one lone electron from the bromine. So those will come together to form a covalent bond. And the other electron from this bond will go to that tertiary carbon. And so seeing where this most stable radical is, that shows us where our halogenation is going to occur. So we can see already that we're going to form, if we had a halogen there, we're going to form D. But let's show one final step to this reaction to see how that could happen. So we mentioned we only get a small concentration of the radicals forming at any time. So we still have a lot of bromine in there. So the way this reaction can continue is if our carbon radical reacts with another equivalent of the bromine. And so this radical can react with one electron from the bromine-bromine bond. So we're forming a carbon-bromine bond to give us this product. And then we're also forming another bromine radical that can continue the cycle, that can propagate this reaction.